I'm going to describe cybersecurity, the challenges of cybersecurity, with a focus on attacks and defenses. My name is Srini Devadas, and I'm a professor of computer science at MIT, and I belong to the Computer Science and Artificial Intelligence Laboratory. I'm going to begin with describing why security is a hard problem. And in particular, it's because security is a negative goal, and I'll get into that. I'm going to talk about the diversity of threat models and why we have to protect against a wide class of adversaries who can attack us in many different ways. Given that I've told you about all of these different attacks, it is going to become clear that we're going to have defensive mechanisms to build into our systems in order to protect ourselves. And I'm going to give you 3 examples of defensive mechanisms that we can put into our systems so they can be secure from the ground up. I want to start with describing examples of recent attacks that have become commonplace. The first of these is an attack on an individual. It's called ransomware. In ransomware, because you've downloaded a virus onto your computer, the virus is strong enough that it's going to be able to take your entire data, encrypt it using a public key that is part of the virus, and delete all of your unencrypted files and email you a ransom note that says, pay me $500 in Bitcoin, me being the adversary, if you want to get the key that is going to decrypt your files and give you your data back. This is something that's happening to people worldwide, and the estimates are that tens of millions of dollars are being extorted from people like you and me using these ransom notes. So that's one example of an attack on an individual. There's been attacks, obviously, on services, and one particular attack that led to the CEO of Target resigning was an attack on Target servers where 40 million credit cards were stolen by cyber thieves. As you can see, there was a lot of damage caused by this attack, and the bad guys made over $50 million by selling this credit card information to other bad guys. And what is sad about this is that there's available hardware security technology, for example, PIN-based credit cards, chip-based credit cards, that could have stopped this attack from occurring. But more importantly, even if individuals had decided to use these credit cards rather than the standard plastic credit cards, each individual would have been protected. So it wasn't a situation where Target had to do something. A particular individual could have chosen to protect himself or herself using this technology that's readily available. My last example of an attack is perhaps the scariest one. It is a nation-to-nation attack, a cyber attack on physical infrastructure. And this attack is called Stuxnet. It was an attack on 14 industrial sites in Iran where a virus got into the Iranian facilities and tried to create damage in the nuclear centrifuges by making them spin faster and faster and decelerating them and accelerating them. Now, how did Stuxnet work? What was interesting about the Stuxnet virus is that it started via an insider attack. There had to be a USB stick with this virus software on it that was introduced into a specific nuclear facility. And so this USB stick had to get plugged in to a particular laptop or a PC inside the nuclear facility. Once that happened, there was a defensive mechanism inside the laptops and the PCs that only allowed certified software to run. By that I mean that computers would only run software that was signed or certified by a legitimate authority. And in this particular case, the attackers stole a legitimate certificate from a company in Taiwan that was supplying certified software to the Iranians. And so you had 2 things happening already, which was software being introduced and software that had been attested. So the software was allowed to run on the laptops. The goal of the software was to discover a particular kind of system that it had detailed specs on, that it knew how to attack in the sense that it could speed up or slow down the centrifuges. So the search aspect of Stuxnet was looking for a system that it could actually control. And through this process, because systems changed, there was actually a situation where the virus was updating itself with new knowledge about systems as the attackers discovered this knowledge. And so the process then continued. The virus propagated across different systems. In fact, it ended up attacking 14 different systems in Iran, probably looked at many more systems than just the 14, but discovered 14 such systems that had exactly the microcontrollers that could be controlled, and these systems were in fact accelerated and decelerated and damaged by the virus. Kaspersky Labs discovered anomalies in some of the nuclear facilities in terms of how they were behaving before this virus could attack the systems for a long period of time. If in fact Kaspersky Labs had not discovered this, it's quite possible that there would have been untold damage to Iran's nuclear facilities to the extent that they might have been a nuclear disaster. It is clear that this was an attack that required resources and knowledge that was clearly at the governmental level. Why do these attacks happen? I described 3 kinds of attacks, and they're all different. Why these attacks keep happening, and why is the diversity of attacks increasing? The basic reason is that security is a negative goal. And let me explain what I mean by that. Suppose I want Franz to prove that he can access a particular file. It's easy enough for Franz to do it because he can open up the file and tell me something that's in it, and I know that he's seen the file. But suppose I want to show that Nick can't access a particular file. That is what I mean by a negative goal. I now have to figure out all of the different ways that Nick could possibly access the file other than the legitimate way of being given the file and reading it. And I have to now show or prove or argue that Nick can't do this. And I'm going to describe to you 10 different ways that Nick can illegitimately or illegally access Franz's file, and you're going to get the sense of why security is hard. For example, if the file is a grades file that Nick, being a student, is not supposed to see because there's privacy issues involved, Nick could attack the system and change the permissions on the file so it's read not just by Franz, but by everybody in the world. Or Nick could have some way through the operating system of accessing the disk blocks directly. And there's no software that protects the disk blocks from being accessed if you can directly access the disk blocks. So that's a couple of different ways. Suppose that the file was connected to web.mit.edu through a collection of other servers. Nick could trace this connection through TCP or what have you and access this file. And at that point, the permissions associated with the file may be fine because web.mit.edu has permissions to access all of the files underneath it. Another way would be to think about what happens when Franz is actually editing the file. It turns out the file moves from disk to memory, DRAM if you will, and in DRAM, access control checks are not necessarily performed. Typically, access control checks are performed when you read from the disk. So once you're inside Franz's editor, you can potentially disable access control checks. Right? So those are 4 different ways, and I can keep going, and I will. You could imagine that there's a backup copy of the file that some editors like Emacs create, the tilde copy, if you use Emacs, that is actually stored, and it's quite possible that this tilde copy doesn't have the same permissions that the original copy has. That might be because of a bug in the Emacs editor or the editor that you're using, but that's another way. Yet another way would be to intercept network packets corresponding to the edits that Franz is making for the file, and when you go back and forth, you're going to be sending parts of the file when you're sending these network packets. And I'm going to keep going here. Nick could send Franz a malicious editor or a Trojan editor that actually just emails Nick the file that Franz opens, and perhaps every file that Franz opens. And if Franz happens to use the Trojan editor, he's going to lose his privacy or lose the privacy of grades.txt. Nick could just walk away with the disk blocks associated with the file, or walk away with the entire disk. And he could go to a warehouse of his choosing and extract all of the files that are on the disk. There are some human ways where Franz makes the mistake of printing out the file, and rather than shredding it, he just crumples it up and throws it into a wastebasket, and Nick grabs it. Yet another way would be to call the system administrator, hoodwink the system administrator into giving away Franz's password by pretending to be Franz. The problem here is that I've given you 10 ways, but I don't know that I'm done, and you don't know that I'm done. There's any number of other ways that I could think of if I spent more time on it. And that is exactly what I mean by saying security is a negative goal and it's really hard to prove security.